Hello and welcome to the fourth video on the properties of shape. This is all about unknown angles. Let's start off with some basic facts that you should probably already know. So if you had a vertex A shown on a straight line along here, what could you say reliably about angles A and B? Well, you could say that A plus B together, both of those angles together, equal 180 degrees. And therefore B plus A would equal 180 degrees. And you could say that 180 degrees minus A would give you B, and 180 degrees minus B would give you A. So if you were given one of these angles, so you were given that this angle was 40 degrees, you could work out angle B from that. You might sometimes see diagrams like this. How many number sentences can you think of that you could write about these angles? Rather like the ones before. So for instance, you could perhaps write that A plus B plus C, in the first one, equals 180 degrees. Pause the video and see how many you can think of. Here are some examples, but there are more. So for the first one, you could do straightforward A plus B plus C equals 180 degrees because they're all on a straight line. Or 180 degrees minus brackets B plus C would give you A. In other words, if you add up B and C together and take them away from 180 degrees, you'd get A. Or you could add A and C together like in the last one. And that's going to be the same as having 180 degrees minus B. For the other one, we need to remember that the angles around a turn add up to 360 degrees. So A plus B plus C plus D, 360 degrees. We can see this is a straight line. So A plus B equals 180. D plus C is another 180. And then you could get into all sorts of complicated 360 degrees minus various brackets equals various individual angles. Can you calculate the amount of the missing angles? So for this first one here, if we know that one side is 120 degrees, then can we calculate missing angle A? It should have a curved line around it like that to show that that's what we're looking for. And for the second one, a little bit more complicated. Can you work out the value of angle A there? So on the first one, 180 degrees would be our angle for the whole straight line. If we take away the 120 that we're given, that will give us A. 120 away from 180 gives us 60 degrees for A, which looks about right. It's not drawn to scale, but you can tell it's an acute angle, so that seems okay. And the second one, there's various ways you could do this. First of all, it's shown you that there are two right angles at the bottom. That's 180 degrees. So actually we don't need to calculate away from 360 here. We can just use the 180 for the top part. So A is going to be whatever 180 minus the other two angles comes to. So I've chosen to add those two together and then take them away, but you could do them one by one. So 180 degrees minus the 127 degrees, which is these two added together, gives me 53 degrees for angle A, which again looks about right. I've noticed, I hope, that I haven't actually been using my protractor for any of these problems, but they are all based on your knowledge of angles. So here's a problem for you. There are 5 equal angles around a point. Can you work out what is the size of each one? And how do you know? So pause the video, maybe draw yourself a little diagram to help you and calculate the size of each angle. So I've drawn myself a tiny little sketch, not to scale or anything, just to demonstrate what we're finding out. And I know that all 5 of these angles are a total of 360 degrees because they're round a point, and I know they're all equal because it said in the question. So I just need to divide 360 by 5, which gives me 72 degrees for each angle, which again would make sense looking at the size of them. Here is your next challenge. 4 angles meet at the same point on a straight line. One of those angles is 81 degrees, but the other 3 are equal to each other. What is the size of each angle, and can you draw a diagram to prove it? So here is my diagram. I've estimated where 81 degrees is. I haven't actually measured it exactly, but it would be probably roughly there. And so I know then that the remainder of that angle on the straight line would be 180 degrees minus 81. That gives me 99 degrees for what I've called A. But there are 3 angles that are all equal in that section there. So I've divided by 99 by 3 to give me 33 degrees for each of those angles. So my answer is 1 angle of 81 and 3 angles of 33. Okay, this is the final problem for today. This is a pie chart, which I interestingly found out was actually invented by Florence Nightingale to show about illnesses in the Crimean War, but that's an extra fact. Anyway, this pie chart shows the colours of cars that have been sold by a car dealership. And you're told that the amount of blue cars sold is equal to the amount of red plus green added together, and that the amount of red cars is twice as many as the amount of green. So your question is to work out the size, the number of degrees for each of those sections. Okay, so for this one, we've been told that blue is the same as red plus green added together, which means that blue has got to be half of the quantity. It's got to be 180 degrees. So 360 divided by 2 gives us 180 degrees. The blue section is 180 degrees, which means we've got 180 degrees left for our full 360 to cover green and red. And the ratio of those is 2 to 1. Red to green. We know that red was twice as many of those were sold than green. So if we add both of those bits together, we've got 3 parts that we can split it into. 180 degrees divided by 3 is 60. So we know that red was twice as many of those to green. So our green is one of those parts, 60 degrees, and our red is the other 2, 120. If we added all that up together, 180 plus 120 plus 60, that would give us our 360 degrees for our full pie chart. Goodbye from me and Florence.